Hello, I'm Mark Scherler, General Manager at FANUC America. Today I'd like to introduce our welding cell that we have here at Fabtech. We have a collaborative robot. It's a CRX-10iA robot that's being used for arc welding. And in this case to weld metal coupons, aluminum coupons, demonstrate what we see a lot in the industry for automotive applications. So the collaborative robot has sensors on it so that if an operator is interacting with the robot, is close by to see how the weld quality is by the robot, if the operator gets in the way of the robot will stop. It makes it a safe environment. The operator still has to have protective clothing on because it's a welding environment, but as long as that's done, then the operator will be safe. This servo torch has a FANUC motor inside that pulls the aluminum wire through the feed system and feeds it out to the end of the torch. We don't have to push the aluminum wire very far. When you have soft aluminum wire, you don't want to push it far because it can cause problems in the feed. It also allows us, by doing that, when we come down and weld on this coupon, we can control the wire feed and match it with the welding process. It's a process that we have at FANUC. Allows the welding robot to move back and forth and change the process parameters of the weld while it's moving. It has strict control on it, so it keeps everything in sync of the motion. The end result is it'll create a part that has a stacked dimed effect. Most people that want to see that type of weld will do it with TIG welding. The TIG welding is very slow, and it's very hard to get an operator to do that type of weld. So to be able to do it with the MIG welding process allows it to do it faster, work on gaps in parts, and also easier to do. So we're going to do that live weld here. All right, so one of the advantages of collaborative robots is that it's easy to teach a new program. So Jake is going to create a program for us using what we call manual guided teach. This allows us to actually generate the program by moving the robot manually and not having to jog the robot through the teach bennett. So he recorded a point up above. He's recording a weld start point right now down in the actual weld joint. He's moving it over to the end of the joint. Maybe we don't have to go the whole way, but he's going to record where the end point is by pushing the button again, and then he's going to bring it back up for return position and record that point. And so now we have a program. If you can see it very quickly, we have a program with the 4 points that he just recorded. It's going to turn off the manual guided teach, and this program we have to set up the weld procedure. So we're going to use a predefined weld procedure on the weld start and weld end, so the user doesn't have to program the wire feed speed, the voltage, anything along those lines. They just have to select the weld that they want. Once they do that, we're ready to play, and the program runs. So we're not going to do live welding here, but this thing could weld right now if we wanted to. So within less than a minute, Jake was able to teach a program and have it running to make a weld for us.